So hello guys, today we are going to solve a question that is not a lead code question today. I'm gonna solve a most frequently asked question. This can be in your college test or college coding test or any other competitive way. Okay. So some people know the brute force solution for this, but I'm gonna be talking about the optimal one also here. The brute force anyone can write, okay, for this, but I'm going to be talking about the optimal one. So what is the question about? First, we'll start by reading this question. Find all the prime numbers in the given range. And you are given a range. Basically, you are given a range from start to the end, and you have to find all the prime numbers that fall in this range. That fall in this range. Assume that the starting and ending number are inclusive. Starting and ending numbers are inclusive. Numbers are inclusive. If I give you an example of this, if I give you an example of what I am saying by this, suppose I am given in the range 1 to 7. 1 to 7. Okay, 1 to 7. So what can be my prime numbers? What can be my prime numbers? What can be my prime numbers? 1, 3, 5 and 7 also. Okay, 7 also. So this 7 and this 1 is also included in my answer. This 7 and this one is also included in my answer. Now this is what I will need to do. First we'll study what are prime numbers before moving on to the solution. For those who are complete beginners and those who don't know what prime numbers are. Okay, basically everyone has studied in their 12th or 10th what are prime numbers, but I am gonna revise it for you. Okay, what are prime numbers? There are two type of numbers. One is prime and one is composite. One is composite. Composite. Okay, so what are composite numbers? Composite numbers are those numbers which are divisible by one and any other number, like more than two numbers. And what are those two numbers? Two numbers? One and itself. Okay, so if the number is divisible by more than two numbers, that is one and itself, is known as a composite number. For example, if I take 8, 8 is divisible by 1 and 8. Okay, but it is also divisible by 4 and 2. Okay, so the number which has many factors apart from 1 and the number itself is known as a composite number. So what are prime numbers? Prime numbers are those which have which are divisible by only one and itself. Okay, so one and itself means divisible by one and itself means the only factors that the prime numbers have is the number 1 and itself. Basically, if I take this case 7, so 1, 7 and 1 are the only factors. 7 is only divisible by 7 and 1. Okay, if I talk about 13, so 13 is only divisible by 1 and 13. 15 is divisible by 1, 3, 5 and 15. Okay, 1, 3, 5 and 15. So this is a composite number. That has more than two factors. Okay, so we don't need composite numbers for this question. I am going to stick to prime numbers for now. Okay, so I have broken down the statement into factors, like it is divisible by 1 and the number itself. 1 and the number itself. So suppose this, if this is the condition that I take, that this is my this is how my prime number is defined. Okay, so suppose if I am given a number x, if I am given a number x, okay, how would I know that this is a prime number? This is a prime number. Bhaiya, you just told that the number should be divisible by 1 and itself. So the only factors this number would have, the only factors the number would have is 1 and x itself. 1 and x itself. 1 and x itself. Okay. But how can I check? How can I check by logic, like by writing code? How can I check this condition? If I tell you, if the only factors are 1 and 0, so can I check? Can I check for 2 to x minus 1? 2 to x minus 1? Basically, if the given number is, suppose I have defined my condition x to be a prime number, only and only if it has 1 and x only as its factors. 1 and x only as its factor. Okay, there is no number in between, that is its factor. But if I start to check from the second number to the x minus 1th number, second number to the x minus 1th number, and if I find that any of the number is dividing x, so that means there are more than two factors for the number. Basically, see, if I take the condition this 8, so 1 and 8, I suppose that this is a prime number. Okay. So 1 and 8 would be a factor for sure. If I want to check whether it is a prime number or not, I'll start by iterating from 2, then 3, then 4, 5, 6, 7, 8, 6, 7. Okay, 6, 7. And I would be checking individual elements like this. If any of them divides, if 8 is divisible by any of them, suppose 8 is divisible by 2 and gives a remainder 0, that simply means it has more than two factors. So it is a composite number. It is as simple as it looks. Okay. What do you have to check? My prime number condition was 1 and the number itself should be is prime factors. Okay. So any other number in the range 2 to x minus 1, if the given number x is divisible by any of these numbers, then it is not a prime number. This is so logical, right? So for every number, I can check whether it is a prime number or not by iterating through. If n is my number, I can start by iterating through 2 to n, and if any of these numbers divide 8 or n, that is n is 8 in this condition, then I will return that it is not a prime number. Return composite. Or if it successfully runs, then I'll return prime number. Because it is then a prime number. Okay, so now I know how I can check for primes, how I can check whether a given number is prime or not. What was my condition? What I had to find? I had to find all the numbers from the starting range, from starting range to ending range, like if this is start is 1 and this is 7, I have to iterate from all of these. I have to iterate from 1, 2, 3, 4, 5, 6, 7. Okay, and I'll check for each of them. I'll check the same condition that I wrote for each of them. And those who satisfy the condition, of a prime number are basically printed. Okay. So if I take this case that I have a range from 1 to 5. Okay, 1 to 5. 1 to 5. So what I have as my numbers, basically 1, 2, 3, 4, and 5. I don't have to check for 1 because it is a prime number for sure. 2 is also a prime number. 2 is the only even prime number. Okay. For 3, what I'll do is, I'll check from 2. I'll check whether it is divisible by 2 or not. I'll check from 2 to 3 minus 1. That is 2 to 2. So I'll check only one condition. Is it divisible? No. So it is a prime number. I'll check for 4. So I have to check for 2 to 4 minus 1, 2 to 3. Okay. So is 4 divisible by 2? Is 4 divisible by 2? Yes. So it is a composite number. Okay. I'll check for 5. Is it divisible by any number from 2 to 4? No. It is divisible by 2? No. It is divisible by 3? No. It is divisible by 4? No. Okay. So this was my solution. I have to check for every number from starting to end whether it is prime or not. And how I can check whether it is prime or not? If it is divisible by any number from 2 to n minus 1, it is not prime. Else it is prime. So if I see the code for this, I have written the code for this. I don't have to write this again. Okay, so this, see, I am checking for the starting and ending number. I am asking for the starting and ending number, and for every number, from every number in this line, I am passing the number. I am passing the particular number to my helper function. And what is my helper function? Basically, I am trying to see if that particular number, suppose I have to find from 1 to 5 and I am checking for 4, so 4 will be passed. 4 will be passed in the helper function. 4 will be passed in this helper function, and the 4 will be checked from 2 to 3. 2 to 3, if it is divisible by any number. See, 4 is divisible by 2, 4 is divisible by 2, so false would be returned. So my 4 would not be printed. If I try to run this code, I specify my starting as 1 and ending as 10. Okay, so what should I get as my answer? What are my prime numbers from range? 1 to 10, 1, 3, 5, and 7. Okay, 10 is not included. 10 is not a prime number. It is included, but it is not a prime number, right? So 1 and 10, I'll press enter, and what I get is, sorry, 1, 2, 3, 5, 7. 2 is also a prime number. Okay, so this was my brute force approach. But if you see that why it is known as a brute force approach, because if you try to see the time complexity of this, basically I'm iterating through all the elements. And again I'm iterating through all the elements to check whether the number is prime or not. Iterating through all the elements from start to end, and for every element, I am checking whether it is prime or not. Okay, so this gives me a time complexity of O of n square. But if I am given the constraints of 10 raised to power 6 or 10 raised to power 7, it would take 10 raised to power 14 operations to execute. That would be like, you can't do this, bro. You can't do this. Okay, so what is my optimal approach? Okay, I'll now see the optimal approach. What is my optimal approach for this question? Okay, so suppose I want to get the prime numbers from 1 to 10. I'll just jot them down. I'll just write them down. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so these are my prime numbers. These are my prime numbers. No, these are my numbers from 1 to 10. Okay, I have to identify the prime numbers. How I can do this? Basically, if you see that 1 is excluded in this case because 1 is obviously a prime number, so we don't need to check for that, right? And 2 is the second prime number. 2 is the only even prime number. 2 is the only even prime number. Now, if we check, if I know that 2 is a prime number, so if I know now that the multiples of 2 will not be a prime number for sure. Why? Because the multiples of 2 will have one more factor as 2 apart from the other two factors, that is the 1 and the number itself. So I can just come to 2 and I can start from 4 and I can just cross it down. Because this can't be my prime number. Why? Because it is a multiple of 2. It has one more factor other than 1 and the number itself. Okay, I can cross this 4. I can come to 6 because 6 is a factor. 6 is a multiple of 2. I can come to 6, I can cross this. I can come to 8, I can cross this. I can come to 10, I can cross this. Okay, so 4, 6, 8 and 10 are eliminated. Okay, 4, 6, 8 and 10 are eliminated. I'll come to 3. Because 3 is not cut. I can come to 3. I can repeat the same thing. That if this is a prime number, that I am considering. Okay, so I can just cancel its multiples, because the multiples are gonna have an extra factor as that prime number. Okay, so I can cancel the elements. 3 into 2 is 6. Okay, I'm not gonna cancel this element. Because why I'm not canceling this? Because if it had been divisible, if this number had been divisible by any other number before that, so it would have been cancelled till now. If it had been cancelled till now, right? If it had not been cancelled till now, that means that it is a prime number, right? If 5 is not cancelled till now, so 5 is a prime number, because if it was not a prime number, it would have been cancelled by now. So 3 into 2, 6. I have already crossed. 3 into 3 is equal to 9. I have already crossed. Now I have crossed as this. So currently my prime numbers are 2 and 3. Okay, I'll move forward. I get this, that it is still not crossed. So I'll get to 5. I'll see from 5 to 10. 10 is already crossed. I'll not cross it again. And this was my max length I can reach. I'll come to 7. And I'll check 7 into 4, 14. Okay, so I'll push 5 also, because 5 is also present, and I'll push 7 also. 7 into 2, 14. 14 is not present. So these are my final, including 1, because we have excluded it. It is the obvious prime number. So 1, 2, 3, 5 and 7. So 5 I'll get as my prime number. This I'll get as my prime number. What is the intuition behind this? Suppose if I say that 6 is a prime number, in starting I am considering all the numbers as my prime number. Suppose I am considering in the range 10 to 15. So 10, 11, 12, 13, 14, 15. I'll check from 2. No, I will not check from 10. I'll check from 2 again. The multiples of 2 will not be a prime number for sure, right? Because as you know, 4, 6, 8, 10, 12 and all the multiples of 2 are gonna be a composite number. Composite number means it has more than 2 factors. 1 and the number itself. Other factors are also there. Okay. So 2 into 7, 2 into 5 for this case, 10 is crossed. 12 is a factor, it is crossed. 14 is a factor, it is crossed. I'll come to 3, I'll cancel its factors. I'll cancel it multiples. Okay, so 15 is also cancelled. Okay, so what is remaining? What is remaining? I'll come to 11. It is not cancelled till now because I'll come one by one. I'll come one by one. 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, and 10 to 11. I'll come to 11. I see that it is not cancelled till now and it is present in my map. Basically, cancelled means that all the elements was 1. All the elements were 1 at the present. And as I'm cancelling, I'll make it 0. I'll make it 0. So whenever I find any 1, I'll simply print it. I'll simply print it, because if it had not been a prime number, it would have been cancelled till now. It would have been cancelled till now. So 11 is my prime number and 13 is my prime number. 11 is my prime number and 13 is my prime number, because it is 1 till now. It is 1 till now. Okay, because now any element before that would not have cancelled them. Okay, if I try to write the code for this that I'm telling, I'll start by initiating a start and the end. I'll just take them as the input. Okay, I'll take them as the input. I'll start from the index 2, because 1 is excluded, I'll start from the index 2. I'll go till end, I plus plus, and for every j I will start, because see, for the second element, for 2 I started from 4. For 2 I started from 4. I'm not cancelling this 2. I'm not cancelling this 2, because if it had been 1, in this case, if it had been 1, that means it is already a prime number. Also, I am declaring a vector which will store, this is of infinite length, that is not infinite length, but this length you can give any length, and I'm marking all the numbers as my prime numbers. 1 stands for prime, 1 means prime, and 0 means not prime. Okay, I'll start from this, I'll go till the end, I'll increment my j value by I. That means that I am just skipping, like 2 into 2, then 2 into 4. So I have to increase 2, right? I have to increase the difference, right? And I'll check this only when I'll get the current value as 1. Okay, because if I'm getting that particular value is 1, then only I'm going to print it, right? And I'm going to mark that index as 0. Now I am starting from the starting index. I'll go till the end and I'll print all the elements. If I try to run it, I'll try for the same test case, that is 1 to 10. Okay. 2 into I, j, okay, I'm getting some error. Why is it printing all the elements? Haha. Okay. Let's see. If v of I equal to 1, then only print this. 1 to 10. 1, 2, 3, 5, 7. As you can see, so what I am doing in my code is, basically I have started to assume all my elements as prime. I have assumed this. Okay, and all I know that starting from 2, I can cancel all its multiples, because 4, 6, 8, 10, 12, if all are gonna lie in my range, I can simply cancel them. Why I'm needing this? Because I'll know that these are the composite numbers. I'll mark them by 0. Similarly, I can do for 3. Similarly, I can do for 4. Similarly, I can do for 5. Okay, and whether I get the current element as 1. If I get the current element as 1, that is in the map, I am getting as 1. That means it is not cancelled till now, and it is not cancelled till now. If it is not cancelled till now, that means it is a prime number, because any number is not able to divide that particular number. that particular number, it is not this particular number is not the multiple of any number that is just occurring before it. So it is a prime number. It is a prime number. So this was my code. If I talk about the time complexity, it is somewhere gonna be of n. Okay, this is performing limited operations, so of n slightly greater than n, but this can be performed, this can work for the test case such as 10 raised to power 7. If the constraints are 10 raised to power 7 in the range, okay, so this code will work. This code will work. Okay, so this was my explanation for the question that I have to find. I have in my question was to find all the prime numbers in the range start to end. Okay, in a specific range, all inclusive, inclusive. The limits, the ranges are inclusive. Okay, so I hope you like the solution. If you have any doubts, just comment it down and just comment it down. Okay, and do like, share, and subscribe. Okay, I hope you like the solution. Okay, bye bye.